Pharmaceutical Engineering BPT 304. Today's topic: flow of fluid, types of flow and Reynolds number. Presented by Shubham Pal, Assistant Professor, Department of Pharmaceutical Technology, JISU University. First of all, what is fluid? Fluid is a substance that continuously flow or deform through a surface. That means it continuously flow without any interruption through a surface. It is a subset of the phases of matter, include liquid phases and gaseous phases. Next, what is fluid flow? It may be defined as the flow of the substances that do not permanently resist distortion. That means fluid flow may be defined flow of the substance without any uninterruption. Okay. Next is various types of flow. Identification of the flow type is important in manufacturing dosage form and handling of drugs for administration. That means in two cases the types of flow are important to identify: in case of manufacturing of dosage form, and second, how to handle the route of administration of the drug. The flow of fluid through a closed channel can be viscous or turbulent, and it can be observed by Reynolds experiment. That means depending on the Reynolds number, the types of flow dependent, whether it can be viscous or turbulent or laminar or transition. First of all, glass tube is connected to a water reservoir, and then the flow of water is adjusted by a valve, and the reservoir of the color solution is connected to another end of the glass tube with the help of nozzle, and the colored solution is introduced into the nozzle as fine stream. Next slide, the diagram representation of that glass tube, nozzle, valve and reservoir of the water. This is the water reservoir, is connected through a valve to the glass tube, and colored liquid is adjusted by a nozzle, and the two type of flow, one is laminar flow and next is turbulent flow. Similar types of flow and the diagrammatic representation of the turbulent flow and the laminar flow. Laminar flow, whether it is water is moving through a layer, and in turbulent flow water is moving haphazardly. Similar diagram, laminar flow, it is moving in laminar flow, the water is moving through a layer, but in turbulent flow water does not move through a layer, it is moving haphazardly. Next is, that means what I discussed earlier, laminar flow is one in which the fluid particle move in layer, and it is laminar with one layer sliding to other. That means the particle in the liquid moving in the layer, and that flow is called laminar flow. There is no exchange of fluid particle from one layer to another layer due to low velocity of water. Due to low velocity of water, in case of laminar flow, there is no exchange of fluid particle from one layer to other. Whether the velocity of water is increased, then the moving particle of the fluid particle are move here and there, it moving haphazardly, and then the mass of the water gets uniformly colored and total color of the liquid will be changed. Then the flow of the fluid is called as turbulent flow. So basically, in case of laminar flow, fluid particle move in layer, does not move haphazardly due to low velocity of the water. When the velocity of the water is increased, the moving fluid particle moving haphazardly, then the thread of the color water disappear, the whole color is changed, uniformly colored. That means the color are uniformly mixed with the water and whole water gets uniformly colored. Then the flow of fluid is called turbulent flow. And the velocity at which the fluid changes from laminar to turbulent, that velocity is called critical velocity. When the velocity at which the fluid changes to laminar to turbulent, the changes of velocity is called critical velocity. So D means diameter of pipe, U means average velocity, rho means density of pipe, and eta means viscosity of the fluid. So D denote diameter of pipe, U denote average velocity, rho denote density of liquid, and eta denote viscosity of the fluid. At low velocity, the inertial forces are less when compared to the frictional forces. That means at the low velocity, first of all, the inertial forces are less compared to the frictional forces. That means viscous forces, and ultimately in the last resulting flow will be viscous in nature. Other hand, inertial forces are predominant, the fluid layers break up due to increase of the velocity, hence turbulent flow takes place. That means when the inertial forces or velocity of the liquid are increases, the flow turn into turbulent, which is already discussed in previous slide, that when the flow of the liquid are increases, the velocity of the liquid increases, the flow turn into turbulent. If Reynolds number is less than 2000, the flow called laminar flow. If Reynolds number is greater than 4000, the flow is called turbulent. If Reynolds number is between 2000 to 4000, it is called transition flow. Average velocity of the turbulent flow is 0.8 maximum velocity, and laminar flow average velocity is 0.5 maximum velocity. So that means at the very first, the inertial forces are less compared to the frictional forces, that means viscous forces. Ultimately, the resulting flow, whether the velocity of the liquid increases, the resulting flow will be the viscous in nature, and whether the velocity of the liquid increases, the flow turn into the turbulent. If Reynolds number is less than 2000, it is called laminar. If Reynolds number is greater than 4000, the flow is called turbulent. If Reynolds number lie between 2000 to 4000, it is called transition flow. Average velocity of turbulent flow is 0.8 maximum velocity, and laminar flow average velocity is 0.5 maximum velocity. And lastly, the application of the Reynolds number. So we already know Reynolds number are used to predict the nature of the flow. That means whether it is turbulent or laminar or transition. This is the main application of the Reynolds number, to predict the nature of the flow, whether it is turbulent or laminar or transition. And lastly, Stokes solution equation is modified to include Reynolds number to study the rate of the sedimentation in suspension. That means to determine the rate of sedimentation in suspension, sometime in Stokes law equation the Reynolds number is also used. So there is mainly two applications. Firstly, the first main application is to predict the nature of the flow, whether it is laminar or turbulent, and lastly to predict the sedimentation rate in suspension. In Stokes law equation the Reynolds are used to modify the Stokes law equation to judge the rate of sedimentation in suspension. Thank you all.